All right, I know we've looked at some calculations for titration already, but this video is dedicated to a specific situation in which you're asked to find the pH of a reaction after it has taken place. So if you take a look at this situation, it is asking us what is the pH of a solution after you mix a certain volume and concentration of H2SO4, which is my acid, to a certain volume and a certain concentration of NaOH, which is my base. Now in grade 11, you might have a different strong acid and a different strong base, right? But you're gonna have a strong acid and a strong base reacting together. Now using my acid and base, I'm going to write my reaction. H2SO4 plus NaOH gives me Na2SO4 plus H2O. Now to balance out this reaction, I'm going to put a 2 here and a 2 here. Now underneath my balanced equation, I'm going to write out the information that I'm given. I'm given both the volume and a concentration of H2SO4. I'm going to convert my volume to liter, and I'm going to write my concentration as well. So I'm given both volume and concentration of H2SO4, and I'm given both the volume and the concentration of NaOH. Now, if you remember from stoichiometry, if you're given both volume and concentration for both of your reactants, if you're trying to figure out how much product is produced, you're going to need to find the limiting reagent first. Now that's exactly what we're going to be doing, but let's understand why we have to do this in this particular situation, right? When you're mixing an acid and a base together, some of it, whatever is available, will react to produce the product. However, if you take a look, we don't have the exact same amount of acid and base, which means that one of it is going to run out first. One of it is going to be my limiting reagent. Now, as soon as my limiting reagent runs out, that reaction is not going to take place anymore, right? So some of it would have reacted off, but whatever is excess, whatever reagent is excess, is going to remain in the solution afterward. And that particular reactant is going to be the one affecting my pH of the solution. Now, remember, the key words here is that the reaction has already taken place. So after this reaction has taken place, the pH is affected by whatever is left over. So in order for me to get there, I need to first figure out which one is the limiting reagent, which one's going to run out first, right? So let's take a look. So I'm going to do this by using one of the methods that I learned when doing limiting reagent, right? And I think this is method 1, where I'm trying to figure out how much product each of these reactions is going to make. And I'm going to choose H2O and compare how much H2O H2SO4 is going to make and how much H2O NaOH is going to make. And I'm going to compare that. Whichever one produces less H2O, that is going to be my limiting reagent, right? So to cancel out my volume of H2SO4, I have to use my concentration. So for 1 liter, I have 0.100 moles of H2SO4. Right, so my liters will cancel out. And in order to figure out how much H2O I will produce, I'm going to use my mole ratio. According to the balanced equation, 1 mole of H2SO4 is going to produce 2 moles of H2O. Right? When I type this all into a calculator, 0.095 times 0.1 times 2 will get me 0.019 moles of H2O. Now I'm going to do the same with NaOH to see which one of these produces less H2O. That is going to be my limiting reagent. And this is going to look the exact same way, obviously using the concentration and the volume of my NaOH. So now I've found out the moles of NaOH. Now I'm going to use my moles of NaOH to moles of H2O ratio. So for every 2 moles of NaOH, there are 2 moles of H2O produced, right? So in this situation, I can figure out the moles of H2O produced from my NaOH. And typing that into a calculator, I'm going to get 9 times 10, or 9.0 times 10 to the power of negative 3 moles of H2O. Now, if you see, this is the lesser amount of moles of H2O produced, right? So therefore, NaOH is the limiting reagent. So I know that when I mix this amount of acid and this amount of base together, my NaOH is going to run out. It's going to be used up in the reaction. And some of that H2SO4 is going to react, but there is H2SO4 that's going to remain in that equation, or in that reaction. So the pH of that solution is going to be resulted from the remainder of the H2SO4. So let's find out how much H2SO4 is left over. So amount of H2SO4 left over. Okay, so if I have to find the moles of H2SO4 left over, I have to first figure out how much H2SO4 I had available, right? So H2SO4 available minus H2SO4 used in reaction. And if you remember back from our excess reagent, how to find how much excess reagent is left over, that's exactly what we're doing here, right? We want to see how much H2SO4 is left over in our solution, because that's what's going to directly affect the pH of the solution after the reaction has taken place. So first, starting with how much is available. 0.095 liters of H2SO4 times my concentration, right? So for every 1 liter, there was 0.100 moles of H2SO4. Okay, now to determine how much of the H2SO4 was used in the reaction, I have to first start off with how much of the NaOH was there, right? That's because how much is used up in the reaction depends on how much NaOH, how much of the limiting reagent was actually there. So going to do that by doing 0.045 liters times 0.200 moles of NaOH divided by 1 liter NaOH. And then I'm going to use the mole ratio between NaOH and H2SO4, right? So I know that the coefficient of NaOH is 2. So 2 moles of NaOH for 1 mole of H2SO4, right? I'm going to just change my color here so I can show you the units canceling out. It's a little bit hard to see, I know. So the liters of NaOH cancel out, the moles of NaOH cancel out, and I have moles of H2SO4 left over. So when I type this into my calculator, so how much H2SO4 did I have available? So 0.095 times 0.1 will give me 9.5 times 10 to the power of negative 3 moles of H2SO4 minus 0.045 times 0.2 divided by 2, which is 4.5 times 10 to the power of negative 3 moles of H2SO4. So what I've done here, I looked at how much H2SO4 was available, how many moles of H2SO4 was available, and I subtracted how much H2SO4 was used up in the reaction according to how much NaOH was actually there. So when I subtract these two numbers together, I'm going to get how much H2SO4 is left over. And that is 5.0 times 10 to the power of negative 3 moles of H2SO4. So if I have this many moles of H2SO4 left over, I can find the pH by finding the pH of this many moles of H2SO4 in that particular solution. So remember that H2SO4 is a strong acid. And here's why in all of the reactions that you're going to see, you're going to have a strong acid, right? We know that a strong acid ionizes completely to form H plus and SO42 minus. So if I have 5.0 times 10 to the power of negative 3 moles of H2SO4, I'm going to have twice that of H plus ions, right? So when I try and find the moles of H plus in that solution, it's going to be twice the moles of H2SO4 that are there, right? So all the H2SO4 that's left over, which would be 5.0 times 10 to the power of negative 3, it's going to ionize fully to form 2H plus. So when I multiply this value of moles by 2, I'm going to get 0.010 moles of H plus. Now remember, pH is equal to the negative log of the concentration of H plus. So what I have here is the moles of H plus. How do I find the concentration of H plus? And that has to do with moles divided by liters. So concentration of H plus is equal to 0.010 moles of H plus divided by the volume. Now let's take a look at this situation. I've got 95 milliliters of H2SO4 and 45 milliliters of NaOH. The total volume of this solution is 95 milliliters plus 45 milliliters, right? So when I convert that to liters, 0.095 liters plus 0.045 liters. So when I find the total concentration of H plus ions, I'm going to type this into my calculator, 0.010 divided by 0.095 plus 0.045. And I use brackets around the denominator here. Now this is going to give me a full answer. I'm going to keep that into my calculator, but I'm going to write out the number here, 0.071428, etc. moles per liter of H plus. So now that I have the concentration of H plus ions, I can just plug that into this formula and get my answer. So remember, I'm going to keep the full number here in my calculator, and I'm going to just do the log of that number. So I'm going to write this on the next sheet. So pH is equal to negative log of the concentration of H plus. So pH is equal to negative log of the concentration, which is 0.071 moles per liter. Now, keep in mind, I've got the full number, right? I'm not rounding here. I've got the full number in my calculator. And when I use that full number to find the negative log of, so negative log of this will give me a number that's 1.146. There are 2 sig figs in this number, which means that my answer is going to have 2 decimal places. So 1.15 is the pH of this solution. So I'm just going to recap what we did here. When the question asks me, what is the pH of a solution after you mix volume concentration of H2SO4 plus this volume, this concentration of NaOH? I first wrote out the reaction and I figured out which one was limiting reagent, right? So that one is not going to affect the pH of that solution at all. What is going to affect the pH of the solution is whatever one is left over. So if I have H2SO4 that's left over, like I did in this question, you're going to figure out how many moles of that H2SO4 is actually left over. Now, you have to take a look at how much of that ionizes to form H+. Now, because this is a strong acid, it's going to fully ionize to form H+. The ratio here is very important. If I had HCl, the ratio would be 1:1, so I wouldn't have to multiply this by 2. But in this case, because it's H2SO4, I do have to multiply it by 2. Now I take that moles of H+, and I have to find the concentration. So I have to divide by the total volume of the solution, which involves the volume of both the acid and the base mixed together or added up together. So I do 0.010 moles of H+ divided by the total volume of solution to get 0.071. And I plug that concentration of H+ into my pH formula to get 1.15. And this makes sense because if I have H2SO4 that's left over, the pH being less than 7 and being very low makes sense because that is an acidic pH. Now, what if you have a question where your NaOH is left over. If your NaOH is left over, you do the same thing. You find the moles of NaOH that is left over, but your NaOH is going to dissociate to form OH minus. You can find the concentration of OH minus and then find the POH, and then the POH can help you find the pH, right? So if this is asking for pH, I can do 14 minus POH to find the pH. Okay?